So in this question, we read that the terminal arm of theta, when drawn in standard position, contains the point px comma y, where p is on the unit circle. So if the cosine of theta is negative 4 over 9 and tangent is positive, so now let's just think about what that's saying there. Cosine is negative and tangent is positive. That puts us down there in quadrant 3. We want to figure out the exact value of the cosecant of theta. Okay, so here we go. And point P is on the unit circle. So if P is on the unit circle, then we know that the cosine of theta is going to be the x-coordinate, and we know that x squared plus y squared will equal 1. So this will be negative 4/9 squared plus y squared is equal to 1, which is going to be 16 over 81 plus y squared is going to equal 1. So y squared will be 1 minus 16 over 81. A little bit of arithmetic, and we're going to get that that's 65 over 81. So that means y could be the positive or negative square root of 65 over 9, which is the square root of 81. So plus or minus, because we were squaring the variable there, there's a little bit of ambiguity as to whether that was the positive or negative value here. Now, because it's in the third quadrant, though, we know that y has to be the negative of that. Now, remember that the y-coordinate is going to be the sine of theta. Okay, so we know that the sine of theta is therefore got to be negative root 65 over 9. And so cosecant, sorry about that, cosecant of theta is going to be negative 9 over root 65. We just reciprocate it. And when we do the rationalization of that, we get negative 9 root 65 over 65. And that answer is B.